In this video, we'll be talking about the Gauss Jordan Method, which involves the matrix or matrices reduced down to or simplified down to reduced row echelon form, RREF, the reduced row echelon form. As we recall from past videos, we used the Gaussian elimination, which involved the systems, the matrices, being simplified down to row echelon form, which is REF. Now, as we look at the 2 by 3 augmented matrix, we see that we have zeros below the diagonals and zeros above the diagonal. With the Gaussian elimination from past videos, it was basically just an upper triangular matrix that had or involved zeros just below the diagonals. In this particular situation, we will be dealing with the Gauss Jordan as these matrices are simplified down to reduce row echelon forms. You will see zeros below and above the diagonals. And all these ones that you see on the diagonals are considered row leading ones or pivot points. So here we have the 3 by 4 matrix, which is basically, as you see, the coefficient matrix of both of these, the 2 by 3 and also the 3 by 4, these are considered the coefficient matrix, right? Coefficient matrix are identity matrices of here is square by or 2 by 2 here square matrix, which is its identity, but here the solution side makes it a 2 by 3, and over here the solution side makes it a 3 by 4. So being reduced down all the way down to its identity, you could say that x is equal to a, y is equal to b, and z is equal to c, or you can say, in some cases, x of 1, x of 2, x of 3. In this case, x of 1 would be equal to a, x of 2 would be equal to b, and x of 3 would be equal to c. Now, what you see here is a 2 by 5 augmented matrix where the row leading ones are here. Okay? And then, of course, you have your solution matrix here. Here's your coefficient side. Here's your solution side. So matrices come in all shapes and all sizes, and you have to be able to understand how to get or reduce your systems down to row leading ones and the pivot points. So let's look at an example. Let's look at an example. Let's say that we have let's write out the systems of equation and just practice in converting into a matrix. So or matrix. So x plus 3y is equal to 11, and then you have 3x plus y is equal to 9. Now, this is a systems of equation. Let's convert it to a systems, or should I say matrix system, uh, which is going to be a 2 by 3 augmented matrix. So as we see, we have 1, 3, and this will be 11. And then we have a 3, and 1, and 9. Now this is involving more work and more calculations. So you have to be very careful and be very responsible for each of your steps so that you may not make a mistake. Everyone and anyone can make a mistake, so you have to pay close attention to all the steps that you're doing, that you're performing. Now, what we want to do, and what I forgot to make mention on the last screen, is you always want to go in a pattern. Now, let's just talk about this 1 second because I wanted to make mention of this. Now, we are talking about a 2 by 3 here, right? So in this case, what we want to do is we want to get a 1 in this position here, a 0 in this position. We want to get a 1 in this position and a 0 in this position. So I like to go on a pattern and do things responsibly in order. Here, and then to here, to this point, and then to here, taking this position and turning it, convert it into 1, and then up here to this position to convert it to 0. So I always like to start here at this point here to get this thing equal to 1. Then go down and make this position equal to 0. Then go over here and make this position equal to 1. And then go here and make this position equal to 0. So you see there's a pattern, right? It's a pattern that everyone should abide by. Now, that keeps you from going all over the place. And as you go to those amusement parks and you try to, you use the little mallet, it's a game to win prizes. You want to hit the, you want to try to hit the squirrels each time the squirrels pop up. Well, it'll be just like that, where you get one squirrel down into the hole and another squirrel down, and then another one pops up. Well, if you go in decent, if you go in order, you get in this position and getting a 1 here and a 3 here, a 1 here and a 0 here, a 1 here and a 0 here, then you want to go in that particular order so you won't have squirrels popping up in each hole. So if you like start here and get a 1 and then go over here, and you get a 0 here, and then of course you go right down here to get a 0 here, and then all of a sudden a 1 pops up there, or another different value, then you'll be having problems like, it's like playing the games at the amusement parks trying to get all the squirrels in the hole, right, to win the prize. So you don't want that. You just want to go in that order so that you can get those values that belong in those positions. And so it makes you come up with the solution much more smoother and easier. Okay. So here we already have a 1 here. We already have a 1 here in this position. So what is our next thing? We want to go here and get a 0 in this position. So now we want to go and say negative. We want to go -3 to row 1, add it to row 2 to get the new row 2. So showing the work and showing the steps, this makes it easier. Just in case you make a mistake, you can go back and correct that mistake and keep on going. So this will be -3, -9, 33, -33, and then we have our second row, which is 3, 1, and 9. So now that we have that, this becomes 0, -8, and what? -24. So here's our new row 2. And so row 1 stays the same. Okay. And then we have 0, -8, and also -24. So now that we have that, what's the next thing that we do? Remember our pattern, right? We went here, we got a 1, the 1 was already given there at this point. So we didn't have to do anything there, but we had to get a 0 in this position, which we have here. Now we have to go and get a 1 in this position, which is already, well, here. We have to get a 1 in this position. So here, we have to get a 1 here. So as we see, a 1 has to be in this position. So we'll do row 2 divided by -8 to get the new row 2. You see that? So this will be 0 over -8, and this is -8 over -8. And so this will be -24 over -8. So we have 0, 1, and we have a 3. So now this is what our new second row will look like. So now what we'll do is let's make sure that you have these notes copied. You can pause the screen and the video, and next we'll go and we'll clear this and continue on with our problem. So here we had 0. Let's go back, make that a little neater. 0, we have 1, and this is going to be 3, as we see. So this here is going to be now 1, 3, and this is 11. What else we have? 0, 1, and 3. So see, we already got this. Normally, this is in row echelon form, which is if we were to use the Gaussian elimination, we'll stop right here and write the system back as a system, or write the matrix here back as a systems of equation, and then solve, because this is like y is equal to what? 3, or we can say x of 1, right? Or x of 2 is equal to 3. But in this case, we have to do one more step because we're using the Gauss Jordan, so we want to get zeros below the diagonal and above. So we're going to make a 0 in this position. So how will we do that? We'll say -3 to row 2 added to row 1 to get the new row 1. So we'll say -3, this is 0, 1, and 3. So this is 0, -3, this is -9. So in this case, this will be 1, 3, 11. This will be 1, 0, and this will be what? This is going to be 2. 9, -9 plus 11 is 2. So now this is now in what? As we write this, 1, 0, 2, 0, 1, and this will be what? 3. So this is now all the way down to reduce row echelon form. So what's our solution? X is equal to what? 2. Y is equal to what? 3. And as an order pair, this is what? 2, 3. Now, just to share something with you, to write it as a solution set, you'll have to write um, your braces here, and that's how you write a solution set, because this is a set, because it has these braces here, right? That's a solution set. This is an order pair. This is a solution set. This is still a solution. It's not a solution set. This makes it a solution set. So depending upon what your professor will ask of you, or if you're using My Math Lab or Cengage, it depends on what they ask you. They ask you for a solution set for your answer in My Math Lab. This is how you would write that, right? It's just a regular solution or order pair solution will be 2 and 3. This is actually where, if you was to actually um, graph both of these systems, I mean, or graph not, well, graph both equations within the system, that uh, it will, the lines will crisscross, and these will be your point of intersection, which makes it your solution, which makes this thing, this system uh, consistent, and also the the uh, the equations to be independent. So that basically will conclude this problem. We what we could do here is, how do I know that these, before we close out, how do I know that this answer here, this solution is the correct solution? So we can run a check. So as we run a check, we're gonna go to the original equation. As we go to the original equation, x plus 3y is equal to 11, we see that we can actually take the 2 and the 3 and substitute it back into where x and y is, right? 2 will go in for x, 3 will go in where y is, and this will be 2 plus 3 times 3. And what's that going to give you? That's going to give you 11, just like this thing here, right? Then we'll have 3 times 2 plus 3 times 3. Now here, that's going to be 6 times, 6 plus, uh, 6 plus, 6 plus, what, let me make sure that we got this correctly. We wrote this right. Okay, hold up. We wrote this out wrong. This second problem here. Hang on 1 second. Let's erase this. Just want to make sure I didn't write anything down incorrectly. Our second equation, that's what I'm trying to, our second original equation. So our second original equation is going to be 3x plus y. So it's going to be 3, let's write in check, 3, 3 times 2, sorry about that, plus, and then y is going to be 3. Yes, I accidentally wrote it down, this down twice by mistake. So that's going to be 6 plus 3, which is equal to 9. So that's going to be alluding to this here. So we know that 2 and 3 are absolutely correct, and that is your point of intersection, and that's the solution to this problem, this system. This system was, or this matrix was converted from a two equations, two unknown, converted to an augmented 2 by 3 matrix to solve this using the Gauss Jordan method. So this will conclude this video concerning the Gauss Jordan method. Stay tuned for example number 2. Example number 2 for the same method, Gauss Jordan.